And our topics for tonight is a general troubleshooting session. We haven't done this before, but I had asked for volunteers to come to send me what their problems were. We only got a couple people responding to that, but the two people who did respond have several questions. So it should be a lively discussion here, and hopefully with the group's knowledge and background, perhaps we can answer a lot of these questions. I noticed that, at least on my screen, they have the live transcript running. If you want to turn that off, you can click at the icon at the bottom, or you can leave it on if you're having a hard time hearing. So that's a new feature of the latest version of Zoom. So
no.
Okay, so the first person who responded with a whole series of questions is Charlie Tomlinson. Charlie, I see you're with us already here. So I have a list of your questions, but I think we'll just have you go ahead and go through the list and ask the questions and see what the group can contribute.
Thank you, Greg. I'm a newbie, so bear with me. I have a C8 with a Telrad. It's got a Hyperstar on it. I use an ASI 290 and a 294, just to give you a sense of my imaging capabilities. And I want to talk about three areas. One is polar alignment. I use Maxim DL and SharpCap to take deep space objects or planets respectively. And I can get Polaris in the crosshairs of those two software packages. But I don't plate solve with SharpCap because I do not have a shorter focal length telescope or a guiding scope. And my question is that good enough for taking deep space objects, say 60 seconds in duration or less? That I know that I'm not on the celestial North Pole with that kind of polar alignment. But the images that I've taken so far are 40 seconds long and they're clear. The deep space object images are clear. So the question is that good for me at this point in my astrophotography evolution, or do I need to go get a scope to mount on that C8 so I can use SharpCap to plate solve and actually get the celestial North Pole?
So Charlie, what kind of scope are you using with your guide camera?
I don't have a guide camera and I have a Celestron 8-inch aperture scope.
Okay, so you're not plate solving to get your polar alignment at all.
Right, because Robin told me at SharpCap that my focal length was much too long, that I needed to get what amounts to as a guide scope to do polar alignment. I think that's what he told me. Don't take
Hyperstar, you've got about a 425 millimeter focal length. So that's really not too long.
Yeah. What mount are you using?
Pardon?
What mount are you using?
AVX.
Okay. I know that I went for a long time with that same setup, never polar aligned. And as long as I kept the images short, like you're doing, I got acceptable results.
Okay. That is very good to know, because at this point, I don't want to invest more in my setup, but I'm happy with deep space objects so far. And planetary objects are different, but I don't think it's a polar alignment issue.
Charlie, do you set up your scope in the same place every time?
Every time.
Okay, well, have you ever tried to do a drift alignment for
No.
both? If you set your scope up in the same place every time, and that's what I do with my backyard scope, it might be worth the effort to put the scope out and then do a drift alignment. Get the scope roughly aligned with the North Celestial Pole, do a drift alignment, mark the spot on your patio or yard or wherever you set up, with blocks or spray paint or a marker,
Right.
whatever, but mark where the tripod legs are. And then every time you take your scope out, as long as you don't change the altitude and azimuth on the equatorial mount, plop that tripod down in the same place, and you're going to be pretty close to polar alignment. And you really only have to do the drift alignment once. So
Okay.
I do that in my backyard. And when I shoot planetary images with a C11 with a 2x Barlow, that's a long focal length. And typically I can keep the planet in the field of view for as long as I need to take a minute or a 2 minute AVI video. So it might be worth the effort of doing a drift alignment, learning how to do it at least, and doing
Right.
it one time, and then don't touch the altitude or azimuth, and always put the tripod back in the same place, and you're going to be pretty close most of the time. And even for the longer exposures than you're doing, you probably won't see much field rotation. And again, a lot of times you can correct for that when you stack the images later on anyway.
Right. Thank you for that, Greg. I've got my patio blocks marked, so those legs sit in the same place, and that helps shorten up the time for polar alignment.
SharpCap does have a polar alignment routine that you do after a star alignment. It's a little tedious, but it's probably easier than a drift alignment. If you look in the help, I think it will maybe show you there. You end up picking a star in the south after you've done a star align, and you go through a routine of moving that around. But SharpCap does have a star alignment built in like that.
Okay, thank you for that. I've also got a little scope mounted in the AVX, but the only way you can get to that scope is either break your back or twist your neck, because it's in a terrible, terrible position. So I
Like
haven't used,
a polar alignment scope,
yeah,
break your back one time and then leave it alone after that. If that's easier than doing a drift alignment.
yeah. Well, just so that you know where I am at this. I want to move on from polar alignment to focusing. For me, focusing is a challenge. And if I use SharpCap doing planetary imaging, it has various focus guides. I paid $5 or $10 for SharpCap focus. And, I can't get those bars in the contrast detection or the FWHM focusing to be constant. You're supposed to be high and green, and that shows good focus. One of my questions, though, is when I've been out and the scene is terrible, that is if I'm focused on Mars and it looks like the exhaust of a jet engine is just to the right of Mars, throwing heat across the disk, is that going to ruin my attempt at focusing?
I would suggest that you, after you star align, go to the brightest star that's available in the direction you're shooting. Right now, something like Regulus, if you're looking east, works well.
Mhm.
And get that centered, and a bright star. And if you want to spend a little money on a batten-off mask, they work very well. And you can get very precise focus and use the sharp cap focus tool that's specifically for batten-off mask. You may have to run your gain way up and to get all the lines to show, but it works great. And
Yeah,
you can get extremely sharp focus with that.
This is Bob Langland, and I would endorse that. That's what I use all the time, is a batten-off mask. And once I do that, I've got a short enough focal length on the scope that for hour or 2 hours, it does not go out of focus.
Okay. Thank you for that. Post-processing is a real challenge for me because I know zero as far as I can see. Do people use PIP for planetary as part of post-processing for planetary images? That is PIPP.
I don't use it, but I know folks do use it to crop the image so that you don't have a big giant black space with a tiny little planet in the middle. I
Right.
think that's the main advantage of it, as I understand, is that you can crop. But most of the planetary cameras, at least the ones I'm familiar with, allow you to do subframes, so you don't really have to do that. For example, when I use my ASA 294 with fire capture, I just draw a box around the planet that's the appropriate size, and record that. So that eliminates the need to have to pick some predetermined size of a field of view, and then later on in post-processing, crop the image down using something like PIP. So that's why I don't use PIP.
There is an alternative in SharpCap. You can reduce the capture area under one of the camera controls and
Right.
cut it way back. And it does two things. It does what Greg says, it eliminates all the black space. But the other thing it does, it gives you a very high rate of frame capture. And then you can, what you need for planetary as well.
Right. Okay. Can we talk a bit about debarring or debarring? I've taken images with Maxim DL of the Rosette Nebula, and for the life of me, I can't get that nebula to be red. I've got nebulosity on my FITS images. I've got 20 images at 40 seconds each. But trying to get the red to come out is alchemy from my perspective. Do you always have to debar your images if you haven't taken color with the camera before in post-processing?
Charlie, if you're using the 294, that's a one-shot color camera, so it will have to be debayered. There is a setting in Maxim that you have to set correctly, otherwise the colors don't come out right. And for the life of me right now, I cannot remember where that's at.
Well, Greg and I went through this a little bit with the Dumbbell Nebula, trying to get the teal to come out back last summer. And so, Tom, I think I understand where you are, and I will go hunting and pecking for that color setting, because the 294 is an RGGB matrix. And I guess I just have to keep on looking. But Tom, you're talking about the 4 values that are either all 0 or 1 0 or 0 1 or 1 1 1 1.
Yes, that's correct.
Okay. All right.
I've got a wonderful image I took with my 294 Hyperstar on a C8 with an AVX, and it's gorgeous.
Yeah. Well,
I think, Tom, the settings I've been using are X and Y 0. And I set the blue to 120 and the green to 80 and leave the red at 100. And that seemed to give a pretty good color representation. And I checked it by taking some daylight images with just a camera lens hooked up to the 294, things that I knew were red or green or blue, just to kind of see, what the different adjustments were. And so in my particular case, the camera needed a little boost in the blue. It needed the green depressed about 20% and to leave the red alone. So that seemed to give the best combination of colors for the 294.
and the
Right.
X,
Can you go through those figures again? What were those numbers once again you used?
I used blue 120, red 100, and green 80. And that's in Maxim DL. That's the way they have it set up. But you could think of it as a percentage, I guess, so that you boost the blue up and chop the green down a little bit. And
Thank you.
yeah, and I think that might be a starting point.
and Greg, your that matrix, that 2x2 matrix were all zeros.
Yeah,
Okay.
I'm pretty sure. I'll try to pull up my copy of Maxim and check that before we finish here.
No, I think with the dumbbell, I think that's what I did was 0.
Yeah, I think that works best for the RGGB. It's just X and Y are 0. Those are just the ones that determine what the Bayer matrix looks like, and I think it's a straight RGGB.
Okay. Those are my questions. Thank you.
All right. Any other comments or questions, follow-up for Charlie?
I would have one. It's Randy. If you're using SharpCap, if you're imaging with SharpCap, you can use the live stack feature. It will give you quite an acceptable image. You can adjust the values. You can adjust the stretching. You can adjust the colors, and people get very respectable images just like that without any other post-processing. So if you're using SharpCap, at least give that a try, and it gets you totally out of trying to learn any post-processing at this point. At least you get some instant gratification that way.
Thank you, Randy.
Yeah, you're welcome.
All right. Any other questions on that?
I could make a comment. Am I coming through? Can you hear me?
Yeah.
Yes.
Yeah, this is Ray Lillard. I'm going to disagree just a little bit. It's not that anybody's right or wrong, but I have a different perspective on this polar alignment thing. I tend to try and get it as good as I can get it. And that I've gotten to the point where that's pretty darn good. And for instance, I have a CEM 25 that I can go 5 minutes without guiding, only if I nail the polar alignment. And so I like to use that rig because I can just go out and set it up somewhere, spend a little bit of extra time fine tuning that polar alignment, and then I don't have to take a laptop and a bunch of other stuff to do that. So one other thing I would point out too is that the sharp cap routine is able to use the pole master camera, which is exactly what I do. I have put a pole master in my mount, and I use that. Even though it's an iOptron mount, I prefer the pole masters to the iPolar alignment camera. So that's just it's a different opinion, and I get different results, but I think going 5 minutes without guiding is a nice thing.
Pole
Another point.
master works very well. It's very easy, but you're going to spend the better part of $300 by the time you get the pole master and an adapter to go on your mount. It works great. And the nice thing is you can do it first, and then your star line goes that much smoother if you've used pole master.
All of those things are true, including the $300.
Yep.
But I would also point out that there's a lot of cheap cameras around that could be just bolted on. I also have a camera that fits on a little dovetail clamp that hangs underneath my Vixen dovetail bar. And I've used that camera as well. So, you know, for $50 or whatever, you can find really cheap cameras as long as they will be recognized by presumably your ASCOM driver is probably what you're using. Anyhow, it's like I said, nobody's wrong here. I just have a different perspective on it. And then the last point I wanted to make was regarding the batten-off mast. Whoever it was that said you use a star is absolutely right, because the planets are big enough that they actually, with your focal length, can be resolved into a disk. And the way the light interferes with the diffraction spikes with each other, if you use a star, which is effectively a point source, you'll get a better alignment.
Okay.
So don't line on Mars or Saturn or anybody. Find yourself a nice bright star. That's it.
The other part of that I would suggest is to make sure that you get a bright enough star and one that's not too bright, somewhere in the middle.
Yeah, you don't want to blow out the core of the star.
Hey, Greg, can I piggyback on that just a second?
Sure.
Randy and I have talked about the batten-off mask in a great deal of detail, and Randy has helped me with that. But I have a configuration very similar to what Charlie has with Hyperstar and a CCD hanging out the front of a 9 1/4 SCD. I do not have, although I may here soon have a dew shield. But is there any sleight of hand or trickery that one can use using a batten-off mask with all that stuff hanging out the front of the scope?
I think you're on the right track to get the dew shield, because even if you have one of those batten-off masks that has a hole in the middle, you're still fighting those cables, and it's a mess. I have the dew shield that I leave on there virtually all the time. You put the mask over the end of that and it works great. And you're focused in no time and very accurately focused. So you almost need the dew shield. Now, if you're on the back of the camera shooting at a higher focal length, then it's no problem. But the dew shield is the answer there.
Yeah, you and I have talked about that, Randy. And there's a whole wide range of dew shields that Celestron makes. I'm just wondering what is acceptable.
The best one is not by Celestron. I forget the company. It's aluminum. It's beautiful. It clamps on very securely. It's very straight, and it has the inside is a non-light reflecting thing. You're going to spend probably $150 for it, but you won't regret it once you have it.
Okay, thanks.
I would add just.
I think that's the AstroZap. Is that dew
I
shield?
think you're correct.
I would add just one other comment to the focusing for planetary. I don't use a Bahtinov mask. I use my eyeballs. And the trick that I found that works fairly well is to turn the gain way up so that the disk of the planet is almost completely white. And when you do that, the limb of the planet will be a really good indicator as to how close you are in focus. Even under poor seeing conditions, it seems to work well. So what I typically do is turn the gain way up so that I can see the limb of the planet very clearly. And then I use the limb of the planet against the background sky to try to get that as sharp as possible. It seems to work fairly well. And I also mentioned that I think as Charlie talked about, when you have really marginal seeing and you're trying to shoot at a long focal length, sometimes it's almost impossible to make sure that you're right at focus. But using a Bahtinov mask or focusing on a bright star and giving it your best shot many times will work, because when you're taking an AVI or other video of the planetary image, you're taking a whole series of images, and the atmosphere is playing as much of a part with focusing as you are fiddling with the focus knob. So the planet may go in and out of focus, but that's why we call it lucky imaging. And when you combine those images later on, you take advantage of the fact that you got the image close, and that at certain frames, the atmosphere cooperated and made the focus even better. So I guess I would say, don't give up when you go out and see that the imaging or the seeing looks marginal when you're trying to do a planetary image, because sometimes you'll be surprised at how moments of really clear seeing kind of stick themselves in there, and you end up with some data that you can actually use.
One of the things that I would also add is that there are ways to modify the Bahtinov mask so that you can actually split it and put it around the hyperstar on a C8 or a C9.25. There are some YouTube videos available on how to do that, and it works a lot easier than trying to unhook everything, put everything back on, and put the Bahtinov mask in place, and then take it all back off again.
Okay.
Good idea.
Thank you, Greg, and everybody.
Well, I'm looking at the participant list here, and the other person who said they had some issues doesn't seem to have checked in yet. And Kevin Cook, are you on with us? Okay, I guess not. Well, since Kevin isn't here yet, we're open. The floor is open for anybody who has questions or other issues that they would like to have some help troubleshooting. This is time to ask.
This is Bob Langland, and this is terribly important. But when I'm doing a polar alignment and I've got a polar scope, I get, and I'm using as a reference to the Polar Scope Align Pro, and then Astrophysics also has a software package, and the results of the two of them are ever so slightly different. And honestly, when I use one or the other, I'm not sure I can really tell the difference in the results. But does anybody have any comments or any experience using either one of those or even both of them? No? Okay, well, I thought I'd throw it out there anyway, see if I got any comments. I suppose
Are you saying that the position of Polaris is different on the two pieces of software?
ever so slightly, ever so slightly.
Well, I'm guessing that if the polar alignment scope is properly aligned, and you get Polaris someplace close to in between those two positions, you're probably going to be in relatively good shape.
I have been, yes, yes. But it's just an interesting oddity that has come up in some of the AP discussion groups, and I've never seen anybody come up with an answer as to why there is a difference, because I know, in fact, I first heard about using the Polar Scope Align Pro, through this particular group, and as a piece of software, it's much more useful than the AP one. But there is a ever so slight difference in the location of Polaris and with the two different pieces of software.
And which polar scope are you using?
The astrophysics one.
Okay. And did you have to calibrate that?
No, it comes pre-calibrated.
So you just stick it in the,
Actually, I'm not sure that's true.
Well, I all the stuff that you get from astrophysics basically says that it is pre-calibrated when it arrives new. Now, that doesn't mean that it can't go out, but so
But
far.
there's also a calibration routine, and
Yes,
I
there
have
is.
I have a Mach 1, and the right angle viewer, I've never used it because I use other things. I use the Polemaster and other routines, but I've always thought, one of these days I ought to go out and calibrate that thing. Just in case my batteries die or something, and
Mhm.
step on my line on my USB cord and can't use it, whatever. And I haven't done it, but I was prowling through the astrophysics documentation one time, and I do recall seeing a calibration routine for that.
Yes, there is. And I have not even tried to use it because I've gotten very satisfactory results right out of the box.
Well, I got the same excuse.
yeah,
Okay.
I'm pretty sure that what astrophysics recommends is that you do a drift alignment and then you put the polar scope where Polaris is and then leave it alone after that. I think that's
That's
pretty
correct.
much what they
Yeah,
recommend.
that's basically what it is. And there's it's basically a 3-point plate alignment. And you put a little tension on the screws, but I have not had to do that. And I've chosen not to do that.
Yeah, it might be pretty close out of the box, but I know that Roland Christian really stresses the fact that the first time you need to, check it against the drift alignment. So,
Well, that's a good idea.
I also have a astrophysics mount, and I believe the difference could be the calculation of atmospheric refraction.
And which particular software does the atmospheric correction?
Actually, the Rapis does have it calculated when it has the point for Polaris. It takes that into account in the application.
I got it. Okay, thank you.
And there's a new app I think it's an iPhone app. I can't remember the name of it, but it has the option of having Polaris with and without with the atmospheric refraction.
yeah, they refer to that as the refracted pole as opposed to the real pole.
Yeah, that's
Okay, that was a good point. Anything else on polar alignment? For Charlie and others who are using Maxim to debayer their images, well, I looked up the values that I was using, and actually it was red was 96%, green 80%, and blue 120% for the ASI 294. So that would probably be a reasonable starting point for that particular camera. I'm guessing that other chips are going to have markedly different values, and you probably are going to have to look at the curves from those cameras in terms of their sensitivity in the different bands, wavelengths there, to decide, do I need to boost the blue up or knock the green down or leave them alone?
Great. That's the reason I asked for those values is I have an Attic 428 one-shot color, and I've struggled with that a little bit, and I've not found any documentation to help me one way or the other. So different cameras, I wonder if that's even a starting point.
Well, I think one of the things to consider is you could start with all three of the channels equal 100% or whatever, but then try different combinations of X and Y for the RGB or for the Bayer pattern. We're going to hear more about the Bayer pattern in a few minutes. You know, and what you may find is that some combination of X and Y being either 0 or 1 is going to give you an image that looks like it's close, and then you can adjust the values of the three different channels, either up or down, to try to get a reasonable color balance.
So that really is a trial by error exercise.
Yeah,
not-
unless you have a piece of software that has that specific camera built in. Now, Maxim has a bunch of cameras in there, but they don't have any of the ASI cameras in there. So you're kind of on your own there. And I'm not sure if they have any of the Attic cameras in or not. Let me look.
Not
We got a bunch of
spec-
DSLRs, but that's pretty much it.
Yeah, not specific.
No, Nikons and Canon, that's pretty much what they do. So I would say try different different X and Y values, because that's going to determine how the software is trying to interpret the Bayer pattern. And then if you get something that's close, then start working on the three different channels. Any other input on that? Well, Sam, since you're up there, you were going to tell us about Bayer patterns, right? For our imaging terminology.
Well, I can speak to it. How
Let's-
much of an education I'm going to provide is another issue.
Okay.
So, you know, when Greg asked me to gave me a couple of topics to speak to, I knew nothing about either one of them, so it was an opportunity to educate myself just a little bit. I had heard, I had seen Bayer in the literature, so that was at least somewhat familiar, and it turned out to be kind of an interesting exercise. And Greg, I have a couple of slides that will kind of help us through
Okay.
this, and so I'm going to share my screen, share my desktop eventually. And that should be coming through. Do you have a shot of M31?
Not yet. You may have to pick a specific screen rather than just the desktop.
That could be as well. How about I select share?
There you go.
Come up, Sam. We see.
Yeah, now you can go there.
There's your desktop.
Yep. See it now.
Okay, does it have the full desktop? I cannot go to slideshow, or at least it's not allowing me to do that.
It's the full desktop.
We're seeing your PowerPoint presentation.
Great, and it is the
in
full
PowerPoint.
screen. Great, and it's the full screen.
No. It's the PowerPoint.
It's a development mode.
Okay, well, when I'm clicking on, it will not let me go there.
That's okay.
Interesting. Well, this, in fact, I really do need to go to that, because some of the slides, we're going to get down into the fine detail.
It should let you do that. Try hitting F5.
And there's an option.
Can you just select the second slide over on the left-hand side. Does that work?
Well, I can select the sides, but you're getting them in miniature version, I think, are you not?
It's acceptable. I can read it.
Well, let's go ahead and go through it then. And as I mentioned, this is by no means an authoritative discussion of Bayer patterns. So those of you who have maybe a better understanding than I do, feel free to contribute to the group. The Bayer patterns, we've talked about it a little bit here just a little while ago in terms of debayering or demosaicing, and we will get to that in just a second. But if you will, just keep a mental picture of Andromeda here, and specifically the star patterns around it, because we're going to speak to those pinpoints of light as we go a little bit further. Back in the 70s, I think it was, the manufacturers were transitioning or trying to come up with a digital source for color photography as opposed to film. And Kodak, I think, was the first, as I understand, and the inventor, Dr. Bruce Bayer, is the one who came up with the idea of pixelating colors. And he invented the concept, and therefore that's what stuck, is a Bayer pattern. I should say right off the bat that there is no single pattern per se or matrix. There are variations all over the map, and other manufacturers have even built their own patterns per se. But the concept of the color for the one-shot color cameras really goes all the way back to Dr. Bayer. And the concept, and we've talked about this as well in the RGGB idea, is that because our eyes are more sensitive to the color green, most of the patterns are in that ratio 2:1:1. And I remember that from my perception days back in school, but I had long since forgotten. The sensors, the pixels within a sensor are really the same, whether it's a monochrome camera or a one-shot color. They're identical, and they simply record the number of photons that strike the respective pixel. In that upper portion there, you can see that a monochrome camera, and this is obviously just a small depiction of a group of pixels. In the color scheme that many of you use with filters, you have monochrome camera and take multiple layers of red, green, blue with some processing, and voila, you come up with a color photo. Well, with a one-shot camera, it's essentially the same concept, theoretically. The pixels accept only the data that it allows it to receive, but there is a pattern of color red GB filters, if you will, and they truly are filters that overlay the sensor and the individual pixels.
No.
And each pixel is filtered by a specific color, either red, green, or blue. And that's what makes the pattern, if you will. And we'll see some examples of that here in just a little bit. But with the one-shot color camera, over time, the technology has become really good. And it is almost more an art than it is a skill on developing these particular patterns of color pixels to come up with a color photo. This is essentially the same concept. It's a little diagram that shows how the specific light frequencies are filtered, and it's essentially the same, whether you're doing individual RGB or LRGB filters and multiple layers and then processing, or if you're using a one-shot color camera, the concept is the same. Each pixel in a one-shot color camera is receiving the photons filtered by the respective color, and you get these kinds of patterns. Now, this is the very last slide that I want to speak to, and unfortunately, we really do need them blown up, and I'm not sure that I can make that happen. But in each corner of these larger shots is a very small portion of the sensor that is blown up in a lot of detail. And I'll try to explain that rather than being able to show it. But the real trick, and we've already talked about it a little bit, is the debayering or the demosaicing of the pattern. The pattern itself, if it was not processed, would simply come out with a bunch of red, green, blue spots. It would not be much of a color photo. It would be generalized, but not very precise, not very attractive to look at. So the underlying photo in each one of these is a shot from the Hubble. And of course, the Hubble is a monochrome camera with lots of filters that, and being processed, ends up with a very nice photo, obviously. But this is a portion of M1 of the Crab Nebula. And in the lower left-hand corner, I know it's going to be tough for you all to see, but A is the original shot with it blown up a little bit to show some color detail. And then B, C, D, and E are four techniques of debayering or demosaicing. And there are many more. These are four that the literature gave as examples, and there were a couple of others that were just almost mind-blowing in the way that they do debayer. But going from the simplest to the more precise or the more technical, the first is called the nearest neighbor. And to debayer in general, it is a function of interpolation, of interpreting individual pixels that may or may not be known. It may not have received enough photons in order to say, yes, this is this color. So it may not be known what that color really is. So a technique, or one of the techniques, is called nearest neighbor. And I hope you can see it, but it is very pixelated. There are squares. Each pixel is coming up with a color there. And this technique is one of the early functions, and some cameras still use this, by the way, when they require a very fast return on the photo. It simply takes a guess, interpolates, but it's a best guess of what that pixel that does not have enough data, what it really or could be. And it is literally a best guess. And how the nearest neighbor function works is that it uses the neighboring pixels that do have good values, and then it makes its guess on what that should be based upon its neighborhood pixels. The next is a little more precise. It's called bilinear. And in this case, rather than neighbors, it draws lines, a couple of lines to be precise, and looks at the pixels along those lines from the pixel that is unknown, and then makes its best guess based upon those linear progressions. The next is D is a smooth hue, and you can't tell a great deal of difference between D and C, those two techniques, bilinear and smooth hue, mostly because rather than a bilinear function of looking at contrast, the smooth hue feature or function looks at color hues and then mixes and matches based on a comparison of hues and then makes that best guess. The last is the most precise of this set of techniques, and it is called the variable numbers gradients. V and G is variable number gradients, and it looks at gradients as opposed to hues or bilinear lines. And if you'll remember the picture of M31 that I showed earlier, where we have some very nicely colored stars in the field, in the star field, but those are very sharp pinpoint objects. So it creates a real problem for one-shot color cameras to handle that well. And the V&G algorithm, along with several others that are even more precise, that have much more computing power, spend a lot of time making that best guess based upon what it knows about the different gradients. So the point is, the pattern itself started to give us the capability to make digital color photographs. And then as technology went along, these processes of bringing the color photo into sharper focus by debayering or demosaicing has given us quite a capability. And astrophysics or astrophotography is the most demanding. The literature said that over and over again, because of the different contrasts and gradients that are in the night sky, that this is the real challenge for the manufacturers, is to develop not only the patterns, the matrices, but also the computing power and the algorithms in order to bring those colors into sharp focus and something that not only looks good, but makes sense. And after going through this, Greg, and learning a little more about this, I am now convinced that I went the wrong way with a one-shot color camera, and I should have gone to the monochrome camera with filters, because by far and away, the better capability, particularly for post-processing, is with that scheme as opposed to a one-shot color. One-shot color still, particularly in the astrophotography realm and the cameras that we have nowadays, provides a beautiful product. But the literature pointed out that the really high-end photographers that do astrophotography are monochrome with color wheels. But something that also got my attention is that it is not just possible, but almost necessary to have a whole savings account worth of filters in order to provide the photos that you really end up and want to have. You can do just basic RGB or LRGB, but if you really dive into it, like I think Randy is getting to a point where he's almost there, boy, you can spend a bunch of bucks on filters. But that is my brain dump. It was a good learning lesson for me to learn more about this, how the technology has expanded over the years and how it came about. It was kind of fun learning all of that. Questions that I might not be able to answer?
That was great.
Thanks, Sam.
Very good, very good. If there are no questions regarding debayering, we have one other guest presenter, Jeff Rothstein. I think Jeff's with us, and he's going to tell us about subframes. Jeff?
As I get going here, let's see if I can handle the challenge of getting the share to work properly. No, I can't see what you're seeing.
We're seeing your PowerPoint.
All right. Are you seeing the whole thing or the PowerPoint screen?
We're seeing the development screen.
Okay. Well, we're going to leave it at that because I run into this problem at work all the time, and it's a challenge with Zoom. So I was asked to talk about subframes, and I spent some time looking into them, and came into the meeting just a couple minutes late, and immediately heard Greg give me a new definition of subframe that I never encountered in my looking. And Greg, if I understood you right, it's the camera has the capability of doing a certain frame size, and with software, as you're capturing the image, you shrink that down around your planet or target to eliminate all the useless background.
Yep.
But I'm going to talk about another kind of subframe as I understand it, and then Sam, if you think you're ignorant, I'm a rank beginner here, so you guys can tell me everything that I've done wrong. So of course, subs are not nuclear in this context, nor are they edible. They are individual exposures of an image for the purpose of stacking together to create an aggregate image, to get an aggregate integration time that is sufficient for creating the image that we're striving for. And this might be the only image I've ever created that I wouldn't be too embarrassed to show you. Like I said, purely a beginner. Now, I can tell you that in a perfect world, you don't need subframes. As a matter of math, the best, if you wanted to take, say, a 2-hour exposure, the highest signal to noise ratio would be a single 2-hour exposure on a device. Problem with that, of course, is there's imperfections in the mount, even those made by the likes of Roland. There are imperfections in polar alignment, imperfections in clouds drifting in, satellites, airplanes, meteors, kids shining their flashlights from the next door neighbor. And so we trade off the risk of that 2-hour exposure not coming out the way we want, because the world is, alas, not perfect. And we take a little bit more noise by getting a whole bunch of images in a period of time, a shorter period of time that allows us to, eliminate the one with the meteor or the one with the kid shining the flashlight. And when we stack those together, we will get a pretty close approximation of, from a mathematical standpoint, of what that original image would look like. And the heart of all of this is that signal and noise both increase as we increase exposure time. But noise increases only in proportion to the square root of the signal. And that's why we take long exposures. The longer we expose, yes, your noise goes up, but the signal goes up by more. And so we are able to get the kinds of spectacular images that I've already, in my short membership with this organization, seen from a number of you. So that's, I was asked to talk for just a couple minutes, and I think I have used up my allotted time. So I'll turn it back to all of you, and you can educate me on all the things I missed.
That was good. And I think I may have thrown you a curveball when I talked about subframes in a different context, but I think the common definition of subframes are just exactly what you described here. And so when imagers talk about how many subs did you take, they're talking about how many subframe images did you take of this particular target in order to stack and come up with the final image, not the subframe that I was referring to that you can sometimes do with some cameras where you can chop out and use just a portion of the chip. So yeah, that was exactly what we were looking for.
In my research, the one thing that's clear is we all still want to take the longest subframes we reasonably can. 10, 30-second subframes are not the photographic equivalent of one 5-minute subframe.
Jeff, this is Bob Langland, and I've kicked this around in my head quite a bit too, because I'm not doing any specific guiding. And so far, I haven't had to deal with other than round stars. But it seemed to me that you can take a 30-minute exposure, and that probably provides you more photons than if you took, 31-minute exposures and think that you're adding them all up and getting the equivalents. In my mind, I don't think they are equivalents. What is your take on that?
So my understanding is when you take the 30 times 1 minute exposures, now any pixel is going to have a certain amount of noise in it, whether it's the sky glow or heat from the sensor or whatever, and it's going to have the active content that we're trying to tease out of it. Every one of those 1 minute exposures is going to have a base layer of noise.
Right.
And so in 1 minute, you can only build up a certain amount above that base layer. Whereas with the 130-minute exposure, you got the one base layer of noise. And the signal can build above that. So that's one difference. It seems that except for that, well, you know what? I better turn this back to the rest of you who have more detailed knowledge than I do as to why it's not the equivalent to take the 30 times 1 minute.
Yeah, that's really the question is 30, does the square root of the noise thing work the same as the square root of the total time? And it just doesn't seem to me that they're totally additive.
It's not that simple. The problem is that there are a lot of different sources of noise. And if you delved into it and looked at the actual equations behind this, they're quite complicated. There's noise, as you're suggesting, that can be reduced by taking the subs and adding them together. That's largely read noise. Every time you try to read out a CD or CMOS camera, the reading device, the reading process injects noise. There's also noise in the pixels themselves. They just sit there, and whether they're cooled or not, electrons magically appear within the pixels, and that's another kind of noise. And there are still other kinds of noise as well. So when you take all those things into account, it's kind of an optimization problem where short exposures, really short exposures are not good, and very long exposures expose you to risks of clouds and what have you.
Sure.
There's another kind of noise in there, and that's the bad pixels. And all our sensors have pixels that are either too bright, they record too many electrons, or not enough dark pixels. And you take subs in order to stack these, you dither them, you shift your camera around just a few pixels and take another picture, so that when you add up all these pixels together, or you take the average of them, you get rid of these bad pixels. So there are a lot of sources of noise. And it's not just a simple square root of the number of subs problem. I wish I knew more about it.
Well,
I've read about it, and I've looked at the equations, and I've thrown up my hands and said, well, it takes a better expert than me. So,
well, certainly taking darks and biases and things like that will eliminate things like thermal noise and things of that sort. But
no, it doesn't eliminate. It's like saying that if I generate a random number between 1 and 10, and I really want to get 0, but okay, so I generate a number between 0 and 10, and I get 3. And you say, well, I'm going to get rid of that by measuring the noise. So I'm going to generate a random number, and you generate 7, and you subtract that from my 3 and say, now we don't have noise. We still have noise. We just have, all we've done is say what the average noise is, 5. And that's what we subtracted out, not the individual pixel noise.
Okay.
I'm sorry, it's deeper than we want to go, I'm sure, but difficult.
Did everyone receive the chat message from me?
Yes.
I sent a chat message. A guy that I know named Steve Canistra has a really great website, and the best explanation for a lot of this stuff, including all those nasty equations that Alex was referring to, he has a pretty good explanation of, as well as some methods you can use to calculate sub-exposures. And it's mainly oriented towards CCD, so it's not really applicable to some of the newer CMOS cameras, but it makes for interesting reading if you're not tired late at night. So the website is starrywonders.com, and it's a /SNR, signal to noise ratio.
Yes, I see it.
So have a look at that, and that will enlarge upon what we've discussed here so far.
And I did come across a much longer article than the Starry Wonders article with at least as much math that completely went over my head.
Yeah, there are whole textbooks written on this.
Oh, I'll bet. But it argued that if you live in a light polluted environment, you're not going to get much benefit by exposures going on the long side. And so you should be comfortable and just keep it short. It's when you get to a dark sky that you really can take advantage of the benefits of all those numbers and squiggles and brackets and squares and square roots and things.
No, the sky noise is one of the limiting factors. And if you look at Steve Canistra's explanation, a lot of it relies on how you can go out and figure out what the sky noise is in your particular location. So, all right, that's great.
Hey, Greg,
any further questions or discussion?
Greg, since we're on this topic,
Okay,
do we have a little bit of time?
sure.
I've looked at a lot of your photos and I've really enjoyed those, by the way. But, I look at the data that you provide showing the number of subframes, the length of the total length of time. And I see that in the magazines as well. Well, I just dove into tracking. As I said, I have a configuration very similar in that with the Hyperstar and CCD camera, I was not guiding, but I could go up to about 60 seconds, and I do a polar alignment. Thankfully, my system, I have a CGM 2 mount, and it aligns very well with a polar alignment, but it's a little painful to go through, but I do that and have no issues. But even with that, I could go up to about 60 seconds. That Chuck and Steve at Starzona recommended that's probably as far as I could go. So now I am guiding and I'm learning and getting into that. But the question that always comes up in my mind, and it's during our star parties that we have out here at Saddlebrook before the COVID age, where we discuss the number of subframes and the exposure times. I'm afraid the answer is going to be another trial and error issue. But is there a kind of a guiding rule of thumb in terms of when you are guiding, in terms of how long the exposure could be, should be, and how many subframes you take? Or is it once again a hit and miss, trial and error, see what you get issue?
Well, again, the website that I referred to, the link to you before, kind of discusses that, and he comes at it from the viewpoint of what's the minimum amount of exposure that you can use to overcome the sky noise and the other sources of noise as well. So you can think of that in terms of the minimum. And in a dark sky location, you can go a lot longer because there's a lot less sky noise. So really there's kind of a floor, but there's really no ceiling. You can go longer. And it's just, a lot of times it's a matter of how well you're guiding, how much time you have to spend on a particular target, what type of filter you're using. So for example, when I'm using color filters, I would maybe shoot a 10-minute exposure, but if I'm shooting through a hydrogen alpha filter, which cuts down a lot of the photons, I might double or triple that, depending on how faint the target is. And again, how well you can guide, how good your polar alignment is, the filter you're shooting through, all of those variables kind of come into play, along with, you know, how much time do you want to spend and how much do you want to try to do a 30-minute exposure and have it ruined by a slight bump of the scope by the wind, or a cable dragging, or a plane that you can't remove with software going through the thing, you know. So most imagers, I guess, you know, they pick a particular length of time that they're comfortable with, that works for the camera system and the focal length and the filters that they're using. And then they stick with that. One other advantage of you know, going through all those manipulations is that when you go to shoot your calibration frames, if you know that you're going to be shooting light frames that are all 10 minutes long or 5 minutes long or 1 minute long, you can shoot your calibration frames to match the same time and hopefully the same temperature, so that you get decent calibration. So again, there's a lot of variables. I guess that's what I have to understand.
I get pictures from observatories down in Chile that I process, and those observatories have fixed exposures that they use for every object that they want, and often it's all done with mono cameras and through filters. But for RGB, their exposures are either 10 minutes or 15 minutes per sub. And for narrow band, they're 20 minutes to a half an hour, or maybe a little more. And they shoot the same thing every time. What they change is the number of subs they take, depending on how deep they have to go to get the object. So if it's a really faint object, you may have 20 to 30 hours worth of total exposure time. Whereas if it's for a fairly bright object, you may have 5 to 10 hours. So
when you talk as amateurs about 20 to 30-minute exposures, is this a permanently mounted?
Oh yeah.
You're not setting up in the backyard every night.
No, these are observatories inside a dome, and these scopes do nothing but take pictures that the owners of the observatory sell to people in the form of subs, so that you can calibrate them and do them yourself. The one behind me is an example of one taken by a CDK 17-inch in Chile. And so this one here had about, I think, 17 hours worth of exposure time.
Oh, but that's a professional setup. Greg, what about yours?
What about, well, same thing. Basically, my scope's in an observatory. It was polar aligned one time, still polar aligned. And I shoot, 10-minute exposures or 15 or 20 minutes through a narrow band filter. And so my calibration library is pretty simple. They're all pretty much 10-minute flats, 10-minute darks. I shoot the darks at different temperatures, but they're all basically 10 minutes. So that makes it pretty simple when it comes time to do the calibration.
I set up in the backyard and I'm using a scope buggy. So I'm moving around each time. but I can generally get close to the same place, but I do polar align each time. As a practical matter, if I'm shooting Hyperstar on the C8, I find that 2 minutes with Hyperstar at 1.8 or what you get a whole lot of exposure there. And if you're a bright object like M42, you can't shoot over 30 seconds without blowing out some of the bright spots. But I'm finding for the average target, 2 minutes does pretty well. If I'm shooting with a reducer, F7 reducer, I'm going to shoot at least 3 minutes. 5 minutes is better, but the practical limit seems to be the guiding quality and how good things are going, how much wind there is, and how good my polar alignment was. And if I get 5 minutes, then I'm pretty good with that. So I'm generally 3 to 5 minutes at F7. 2 minutes is about all I will shoot with Hyperstar. This is all one-shot color. But I find guiding is the biggest issue to limit my time.
There's a reason why they call it Hyperstar.
Yeah.
It's
What's
extremely
the F
fast.
ratio? What's the F ratio of the Hyperstar?
It varies on the scopes. At a C8, it's something under F2. It's probably 1.8 something. So it's extremely fast.
Yeah, see, that's the difference, because that's easily equivalent to what I'm getting with the CDK 17, which is, I think, an F6.8. And so, you scale those things by the square, and your 2 or 3 minute exposure is probably equivalent to a 15 or 20 minute exposure on the CDK.
So it's a big benefit. Of course, you're like on the C8, you're about 390 millimeter focal length. So you're kind of limited to the bigger objects. If you want to shoot the vast, after you get by Andromeda and a couple of other, well, really only one, Triangulum, you almost need to go to the reducer, and then I'm in much longer exposures. The other factor is when you get to stacking, if you shoot 100, it's going to take a whole lot longer to stack 100 images than it is 25. So it's a benefit when you come to processing to have fewer frames. So,
It's all a trade-off.
yep.
One of
All
the things,
right. Any other comments or questions?
Greg, I've got one thing that I'd like to bring up. Been a lot of discussion about focusing and a lot of discussion about guiding. One of the things I found in both focusing and guiding, that it's important that when you pick the star you want to focus on or the star you want to guide with, it's not too dim and it's not too bright, because in both cases it affects how the mount and the software in the mount actually operate. I've gotten uniform 1 arc second, maybe 1.2 arc seconds on my AVX by making sure I select a guide star is the right size and brightness, not too big, not too bright. And the same thing goes with my focusing. I found that if you go too bright, it doesn't work. If you go too dim, you don't get enough of a pattern from the Bayer mask or from the focusing routine that you're using to really get the full wave half max peak.
Interesting. What kind of software are you using with the guide camera?
Right now, I have converted both of my telescopes to using the ASI Air Pro, and I use that to capture the image. I processes my image in Maxim.
Okay.
I think the ASI Pro is using a version of PhD 2.
Oh, okay.
Yeah.
Correct.
I since I haven't been doing any guiding, but I'm intrigued by it, and it seems to me, from what I understand, is the PhD 2 is probably the gold standard right now. Yeah, I'll throw that out, and if anybody's got any opinions to the contrary, it'd be interesting to hear.
I've been very happy with the limited version of PhD that I have on the SIR Pro. I use a EQ6R Pro mount for my 11-inch, and I routinely get half an arc second guiding. For my AVX, I can reliably get between 1 and 1.5 arc seconds in guiding.
Thank you.
Tom, what do you consider an in-between, not too hot, not too cold star, the Goldilocks star? For folks.
By name?
How about magnitude?
Yeah, magnitude.
Yeah, well, again, I do most of my guide scar selection visually based on the image taken with my guide camera. If it's really, really faint in the guide camera image, that's no good. If it's really bright in the guide camera image, that's also no good. It's got to be somewhere in the middle. So if you would say a dim star is, let's say, a magnitude 12 to 14, and a bright star is a magnitude 2, I would look for something in the magnitude 7 range.
PhD will auto-select something it likes as well. And the ASR Pro, it will auto-select.
That's true.
You basically don't want the star to be so bright that it saturates the chip, because that screws up the calculation of the point spread of it when it's trying to analyze where the star is supposed to be.
Having a slope on that point spread function actually kind of works for you rather than against you also. If you have a guide star that's just like 1 pixel, you're not going to be happy. And I would also say that PhD2, I haven't had time to an opportunity to use PhD2 recently, but there's been a release that does some sort of centroid calculation or some sort of integration between a handful of stars to help with seeing. And I'm still I'm out in California. I haven't been back to Tucson in a while, but I'm going to be back in a couple of weeks and I'll get to try it. But from what I hear, it's good news. One other thing while I got the floor regarding the CMOS camera and the length of exposures and gain settings and such. Robin Glover has a YouTube video that lasts about an hour, as I recall. It's been a while since I've watched it. And he goes through all that sort of stuff in a visual presentation he made. And the math is pretty simple, but you know, it's one of these things where I watched it, sections of it, I watched it multiple times because he does go pretty fast. So I put that out there too. I'm out.
Greg,
Okay.
something as a follow-up to Sam Miller's techniques of debayering. I was reading a ZWO forum, and they were impressed with Astro-Pixel Processor's airy disk debayering technique. Now, I've never used it, but I just report that they thought that that was superior to other techniques for debayering.
I'll have to look into that. I know we used to have a couple of folks in the group that used APP. I'm not familiar with it though.
Neither am I. Just have read about it.
Okay. All right. We're getting pretty close to our time. Just our next meeting is scheduled for April 26th. That's a Monday. And I'll send out a notice, of course, and this is when you get a chance to speak up. And if you have any particular topic that you would like to have someone address or that you'd like to address, we'll certainly put it on our schedule for the next one of the next several meetings.
One of the things that I'd like to stress is you don't have to tell us right now. You can send either Greg and I or email of a topic that you'd like to see, or, processing information, maybe even what do you look at right now in this time of the year? So any of that stuff is open and welcome. So don't feel that you got to respond right away, but think about it and send us a note.
Sounds good. All right. Thank you, everybody, for participation. I think this went really well, and we'll have to keep it in the hopper for maybe a future meeting down the road a couple of months.
Thanks. Thanks.
Thank
Greg.
you. Very interesting.
Thank you.
Thank you very much.
Okay.
Bye.
That's all.